Hi everyone. In this video, we are going to see how to convert the general form of the equation of a straight line into three other forms. The general equation of a straight line is denoted as a times x plus b times y plus c equals 0, which I have it here on the left hand side, and then we are going to try and convert it into these three other forms. The first form is y equals mx plus c. Well, sometimes some authors might call it as mx plus b, but whatever that may be, it's actually y equals the slope times x plus the y-intercept. And the second form is x over a plus y over b equals 1, where a is the x-intercept and b is the y-intercept. So that's the second form. And the third form is x times cosine alpha plus y times sine alpha equals p, where p is the perpendicular distance from origin to the straight line and alpha is the angle that the perpendicular line creates with the positive direction of x-axis. I have already created separate videos on these three different forms of equation of straight line. I have provided the link in the description. Feel free to watch them. And here we are going to see how we can convert the general form of the equation of a straight line into these three different forms. So let's get started with the first form. We want to convert it into the first form, which is y equals mx plus c. So what we need to do, we need to isolate y. So how can we isolate y? Well, from here we can write it like this. We can say by or b times y is equal to negative ax minus c. And now if we divide both sides of the equation by b, assuming that b is not 0, then we get y equals negative a over b times x and then minus c over b. And now we see that the equation has been converted into the y equals mx plus c form, because if you imagine this to be the m and if you imagine this to be the c, then clearly this is m times x plus c. Because it has a negative sign, I have enclosed that within the rectangle, but again you can imagine that c over b is actually the c in the y equals mx plus c form, which is actually the slope-intercept form. Here the slope is negative a over b and the y-intercept is negative c over b. So I'm just going to write it as m times x plus c. So now you see that y equals mx plus c form has negative a over b as the slope and negative c over b as the y-intercept. Let me make a quick note here. So m is the slope and c is the y-intercept. Next, we are going to see how to convert the general form of the equation of a straight line into the intercept form. So if this is the general form of the equation, then from here, let's isolate x and y on the left hand side. So we have ax plus by can be written as minus c or negative c. And then if we divide both sides by negative c, then we have a over negative c times x plus b over negative c times y is equal to 1, and we are almost there. So from here what I am going to do, I am going to write this as x over negative c over a. Can we write it like that? So x over negative c over a plus y over negative c over b is equal to 1, and that is the intercept form. So in the intercept form we have x over negative c over a, that is the x-intercept, and then plus y over negative c over b, that is the y-intercept. So if we are ever given the equation in the general form, then we can easily find out the x-intercept and the y-intercept. Now let's talk about the third form, which is the perpendicular form. So now we are going to try and convert the general form of the equation into the perpendicular form. To convert this form into the perpendicular form, which kind of looks like this, x times cosine of alpha plus y times sine of alpha is equal to p. And here one interesting thing that we have to realize is that the coefficient of x, which is cosine of alpha, and the coefficient of y, which is sine of alpha, and if we take a square of those two coefficients and we sum them, this should be equal to 1. That's a Pythagorean identity from trigonometry. Sine square theta plus cosine square theta is equal to 1, or sine square alpha plus cosine square alpha is equal to 1. So in this case also, we have to convert the general form into this perpendicular form in such a way that the coefficient of x and the coefficient of y become such that the sum sum of their squares would be equal to 1. Now here we see that the coefficient of x is a in the general form and the coefficient of y is actually b in the general form. Now here we are going to try and find out what is that factor or what is that quantity that we need to multiply here on both sides of this equation so that the coefficient of x and coefficient of y becomes such that the sum of their squares would be equal to 1. So let's assume that we have to multiply by k on both sides of the original equation so that we get a coefficient of x and coefficient of y in such a way that the sum of their squares would be equal to 1. So if we multiply both sides of this equation by k, let's say suppose a times k times x plus b times k times y plus k times c is equal to 0 times k, that is 0. And now k's value has to be such that a times k whole square plus b times k whole square, this has to be equal to 1, and then only we can easily convert this into the perpendicular form. So now from here let's try to find out what should be that k then. Well, it is a squared times k squared plus b squared times k squared is equal to 1, and from here we can say, well, k squared is a common factor, then we have a squared plus b squared is equal to 1, and from here we can say, well, then k squared is equal to 1 over a squared plus b squared, and from here we can say then k must be equal to plus or minus 1 over square root of a squared plus b squared. So far we have found the factor that we need to multiply on both sides of the original equation so that the sum of the square of the coefficient of x and the coefficient of y, the sum of their squares would be equal to 1. Alright, now let's try to convert the original equation then. Well, our original equation is like this. Let me use a different color here. So again, ax plus by plus c is equal to 0, and if we convert this into a form like this, let's say ax plus by is equal to negative c, and now we are going to multiply by this factor, which is this one right here. We are going to multiply by this factor, right? Now the question is whether we should multiply by the positive value or the negative value of k. That's something we have to decide here carefully. Since p in the perpendicular form, this p up here, the p that we see up there, this p, that has to be a positive number for the perpendicular form. So p always has to be positive. So now if we have to have a positive quantity on the right hand side, then now let's think about the sign of this negative c right here. If c itself is a negative number, then negative c will be a positive number, and if c itself is a positive number, then negative c would be a negative number. But somehow we have to make sure that the right hand side is always a positive number. So then there are two cases. If c is actually negative, so let me make a note right here. Let's assume that c is negative. That means negative c would be a positive number, so our right hand side is just fine. Then all we need to do is we need to multiply by the positive value of k. So when c itself is a negative number, then we are going to multiply by the positive value of k. So it would be a times k, and k we are going to use the positive value, so that would be 1 over square root of a squared plus b squared times x, of course, plus b times k, again 1 over square root of a squared plus b squared times y, of course, is equal to negative c times 1 over square root of a squared plus b squared. And if we simplify this little bit, we can write it as a over square root of a squared plus b squared times x plus b over square root of a squared plus b squared times y is equal to negative c over square root of a squared plus b squared. And that is the perpendicular form, where the coefficient of x is equivalent to cosine of alpha and coefficient of y is equivalent to sine of alpha. So if we imagine this quantity to be cosine of alpha, and then this quantity to be sine of alpha, and finally this quantity to be p, then this looks like x times cosine of alpha plus y times sine of alpha is equal to p, and that's the perpendicular form. Now we have one other case where c is positive. So let's see what we need to do when c is positive. When c is positive, then negative c is a negative number which is on the right hand side, You see up there negative c that we have on the right hand side, that's a negative number. Then if c is positive, then we have to multiply by the negative value of k, right? So k has two possible values, a positive value and a negative value, and now we are going to use the negative value of k so that our right hand side becomes a positive number, because in the perpendicular form the right hand side has to be a positive number. So now we are going to use the negative value of k, and then we can say that our equation is going to look like this: a times negative 1 over square root of a squared plus b squared times x plus b times negative 1 over square root of a square plus b squared times y is equal to negative c times negative 1 over square root of a squared plus b squared. And if we simplify this little bit, we can write it as negative a over square root of a squared plus b squared times x plus negative b over square root of a squared plus b squared times y is equal to positive c over square root of a squared plus b squared. And now if we consider this to be cosine of alpha, and then we consider this to be sine of alpha, and we consider this to be the p, so now our equation looks like x times cosine of alpha plus y times sine of alpha is equal to p. So that is how we can convert the general form of the equation into the perpendicular form. Always remember that in the perpendicular form, the right hand side is always a positive number, that p indicates the perpendicular distance from the origin to the straight line. So that's always a positive value. So somehow we always have to make sure that that perpendicular distance is always a positive number. And that is why, depending on the sign of c, we have to decide whether we need to use a negative value of k or the positive value of k, right? I hope it is clear up to this point. Now we are going to take an example and we'll convert that into the three different forms. So now let's take an example. Let's suppose we have been given an equation like this: 3 times x plus 4 times y minus 5 equals 0. That's the general form of the equation of a straight line. And from here, we're going to try and convert this form into the three other form. Right? So let's first try to convert it into the slope-intercept form. So our first attempt would be to convert it into y equals mx plus c form. So now let's first write it down. Our original equation is 3x plus 4y minus 5 is equal to 0. And if we isolate y from here, then we can say 4y is equal to negative 3x plus 5, and if we divide both sides by 4, then we get y equals negative 3/4 times x plus 5 over 4, and that is the slope-intercept form. And here the slope is negative 3/4, that's the slope, and the y-intercept is 5 over 4. Let's try to convert it into the intercept form, which is x over a plus y over b equals 1. So now let's try to convert that into the intercept form. So now I'm going to use a different color. Our original equation is 3x plus 4y minus 5 is equal to 0, and from here if we keep the x and y terms on the left hand side, then we can say 3x plus 4y is equal to 5, and if we divide both sides by 5, we get 3 over 5 times x plus 4 over 5 times y is equal to 1, and from here we can write it as x over 5 over 3 plus y over 5 over 4 is equal to 1. So now we can see that the x-intercept is 5 over 3 and the y-intercept is 5 over 4. I hope it is clear up to this point. And then we are going to convert it into the perpendicular form. To convert it into the perpendicular form, first thing I am going to do is bring the constant term onto the right hand side. So our original equation is 3x plus 4y minus 5 is equal to 0, and if we write it like this, 3x plus 4y is equal to 5. So we already have a positive number on the right hand side. So to convert this into the perpendicular form, we are going to multiply by the positive value of k, and in our case what was k? Well, k was like this, plus or minus 1 over square root of a squared plus b squared, and because we already have a positive number on the right hand side, we are going to use the positive value of k to convert this equation into the perpendicular form, right? So what would be the positive value of k? That would be 1 over square root of a squared plus b squared. So let's multiply both sides of our equation by that value. So we can write it as 3 over square root of 3 squared plus 4 squared, because A is actually positive 3 and B is actually positive 4 in our given equation. So 3 over square root of 3 squared plus 4 squared times x plus 4 over square root of 3 squared plus 4 squared times y is equal to 5 over square root of 3 squared plus 4 squared. And if we simplify this will reduce to something like this. It would be 3 over square root of 9 plus 16, that's 25, so 5, so 3 over 5. So we can say this is 3 over 5 times x plus 4 over 5 again, 4 over 5 times y is equal to 5 over 5, and that is equal to 1. So again, if we rewrite this, we can say then 3 over 5 times x plus 4 over 5 times y is equal to 1, and that is the perpendicular form. And in this perpendicular form, what is the cosine of alpha? Well, cosine of alpha would be 3 over 4, which is positive 3 over 4. That would be the cosine of alpha. And what is the sine of alpha? Well, sine of alpha would be the positive 4 over 5, that is sine of alpha. And what is p? Well, p is actually positive 1, which is right here on the right hand side, so that is our p. So this is how we can convert the general form of the equation of a straight line into the 3 other forms of equation of a straight line. I hope everything made sense. Thank you for watching. See you in the next video.